Sound is the vibration of air. The air can vibrate stronger or weaker. So we hear it as the volume of the sound. Sound can also oscillate faster or slower. So we hear it as the pitch and color of the sound.
People can hear vibrations of the air at a speed of 16 Hz and up to 20,000 Hz. Vibration of air slower than 16 Hz is called infrasound, and vibration of air faster than 20,000 Hz is called ultrasound. Humans cannot hear ultrasound and infrasound. The sound we hear is therefore a combination of stronger and weaker, and faster and slower air vibrations between 16 Hz and 20 kHz.
In order for sound to be transmitted over long distances using electromagnetic waves, it is necessary to convert it into an electrical signal using a microphone. The better the vibration of the voltage imitates the vibration of sound, the higher the quality of the conversion of sound into an electrical signal. The oscillation of the obtained voltage on the microphone is, therefore, analogous to the oscillation of sound, so such an electrical signal is called analog. When transmitting sound by radio waves, the electrical signal is amplified in an amplifier, modulated and taken to the transmitting antenna where the flow of electric current through the transmitting elements of the antenna generates and transmits an electromagnetic wave. This way of transmitting sound by radio waves is called analog signal communication. The carrier of sound information in this case is an electrical voltage whose values change as the sound changes. Given that unwanted noise and interference signals can be superimposed on the analog signal during signal transmission within a certain space, the quality of the signal is impaired on the receiving side. The sound produced from this corrupted electrical signal differs to a greater or lesser extent from the original sound, from which the electrical signal was obtained. As a result, the quality of radio communication is impaired. By amplifying the received signal, damaged by interference, not much can be achieved, because along with the useful signal, noise and interference are also amplified. The most in the fight against noise and interference in these systems is achieved by emitting signals of the highest possible power. Noise and interference have long been a major headache in radio communications. This is why digital signals are gradually being introduced into radio communications, especially satellite ones. Voltage as a carrier of sound information is replaced by combinations of logical bits 0 and 1. During radio communication with digital signals, as well as with analog signals, the signal is damaged by noise and interference. However, the fact that the voltage of the digital signal will be damaged by noises and disturbances does not reduce the quality of the transmission at all, as long as this damage does not threaten the correct reading of whether it is a logical 0 or 1. This is because the digital signal does not transmit sound information by voltage, but by a combination of logical 0 and 1. As long as those combinations are read correctly, regardless of signal degradation, the reproduction is the same as if there were no noise and interference at all. Let's take for example, that with an analog signal, the voltage representing the sound at one time is 5.2 volts. Those 5.2 volts are transmitted in the digital signal by a combination of 8 logical bits. After long-distance transmission, noise and interference are added to both analog and digital signals. In the case of an analog signal, on the receiving side, this will result in incorrect voltage readings and incorrect sound reproduction. With a digital signal, this will not happen because, regardless of the distortion caused by noises and disturbances. The combination of logical zeros and ones will be correctly read and based on it. A voltage of 5.2 volts will be generated, in the same way as if these noises and disturbances were not present at all. There is none.